welcome back to another session, guys. Thank you guys for joining me again as we continue on the limits of functions. And if you enjoyed the first example, guys, please, I really hope that the second example will help you to understand better. But if you are not part of the family, please hit that subscribe button, guys. If you feel like these videos are helping you, they might help somebody else as well, please share, guys. Please recommend the YouTube channel to other people. Without wasting time, guys, let us have another example on limits of functions. So as I said, limits of functions that we are doing here are just basically from calculus 1. Okay, so calculus 1 is the one that we are doing here. So I just write it here, cal 1. Okay, so it's from calculus 1. Guys, you can use these approaches every where you are required to find the limit. Now let us have another example as I promised. Now the second example, they say to us, let us find the limit as x approaches 1 of x cubed minus 1. Okay, of x cubed minus 1. Now, as I said, guys, how you view your function, yes, how you view your function will alter how you approach your question. Okay, so be careful on how you view your questions. So let us have the solution of this question. So with the first approach, the first approach is the one that we wrote here, numerical approach, which is the table approach. So we will have it as, now we are looking at the limit as x approaches 1. It's the same as that one. So I'll just randomly choose values which are relatively close to 1. Okay, I'm just choosing values which are relatively close to 1. And I'll just, this time, because I want to have a lot of space, I'll just start from 0.8, 0.9, and then 0.99, and then 0.999. Okay, for us to have space, guys. Otherwise, I would have started at 0.5. I mean, yes. Now, I'm going to take my calculator, gonna introduce this function there. So it's just going to be x cubed. But now I'm not going to write x cubed because we are going to be substituting there. So I won't write that. So wherever where I see x, I'm just going to introduce brackets. Now let us start with 0.8. Okay, so 0.8. So the first value is 2.44. Okay, so we write it here. So it's going to be 2.44. Now let us substitute 0.9. Substitute 0.9. So with 0.9, what do we get? 2.71. 2.71. 0.99. Okay. 0.99. 2.97. 2.97. 0.999. We get 2.997. So let's write it as 2.997 because yeah. Now let us look at it approaching from the left. Okay, so we're looking at the approach from the right. I mean, this is the approach from the left. Sorry, my handwriting is terrible, guys. Okay, from the left of 1. Now we're looking at it from the right of 1. Now we have x, f at x. So we're choosing values which are relatively close. 1.001, 1.001, 1.01, 1.1, and 1.2 for us to have space relatively close. Substitution 1.0001, 1.0001. So we get 3.00. So we get 3.00. Okay, so let us check for the second one. Just take down 1 0 1.001, so we get 3.00 again, and then we take down another 0, 3.03. okay, so we take down all the zeros that we have now. 1.1, so we get 3.31, and then we look at 1.2 now. 1.2. Now we get 3.64. As you can see, guys, as we move away from 1, the values of y are increasing drastically or exponentially. Okay, so this is from the right of 1. Now you can see that the limit, you see that as the x values approaches 1 from the left of 1, the values of y are approaching 3, because 2.997, if you take it to the nearest, if you take it to 2 decimal places, then it's going to be equals to 3. And then when you see that we're approaching 1 from the right of 1, then we are going to get 3 as well. So thus the limit as x approaches 1 of x cubed minus 1 over x minus 1, it's equals to a 3. Okay, now let us go to the second approach. Now the second approach, I'm just gonna write O. The second approach is the tabular approach. Now with this one, the type of a graph that you're going to see is going to be a beautiful graph. I don't wanna give it away yet, so let me do this. So the type of graph we are going to have here, it's actually a graph like this. Now this graph is going to have, okay, let me just try to draw it down. So this is just 1. So this graph is something like this. It's something like this. So what type of a graph is this one? We all know it is a parabolic function. So this parabolic function is just a parabolic function of f at x is equals to x squared plus x plus 1. Okay, x squared plus x plus 1. So since we have got x squared plus x plus 1, this doesn't have x-intercept. Okay, you can see that it doesn't have x-intercept, plus x plus 1. Okay, so let us see what happens now. If our x is 1 here, what is the corresponding y value? So f at 1 is going to be given by, f at 1 will be given by, f at 1 will be given by 1 plus 1 plus 1, which is equals to a 3. Okay, so this means that if we're approaching x from the left and approaching x from the right, the function approaches 3 from the left and it approaches 3 from the right. Okay, because the values will correlate with respect to the movement of all x values. Okay, now the relationship of f at x, okay, let me leave that one for now. Sorry, I was getting super excited now. Now this will convince us that the limit as s approaches 1 of x cubed minus 1 over x minus 1 will be equals to a 3. Okay, so we are convinced, we are highly motivated that this is true. Now let us look at the third approach. Let's look at the third approach. The third approach is given by the analytic approach. Okay, the one that we like the most. So we have the limit as x approaches 1 of x cubed minus 1 all over x minus 1. So this is a difference of 2 cubes. So we'll have the limit as x approaches 1 of x minus 1 and have x squared and have plus 1. Okay, because it has to be minus 1. So we just have this multiplied by that, and then we just take the opposite sign. Plus x times 1 is just x. divided by x minus 1. So this and that, they go to town. Have the limit as x approaches 1 of x squared plus x plus 1, which is just equals to 3. Okay guys, if you came this far, please hit the like button, please hit the subscribe button, guys, as it helps with the algorithm, and it helps with the recommendations for the YouTube. So guys, if this is helping you, I will not finish saying this, that please share the videos, please recommend the YouTube channel. I'll see you on the next one. Thank you.